This video will provide a review of how to find the least common multiple, which is also the least common denominator when we work with rational expressions. So first, a little bit of review about fractions that just involve numbers. Most people remember how to find a common denominator when there's just numbers in the denominator. If you have 3/10, 2/15, and 1/3, your common denominator is going to be the smallest number that all three of your original denominators divide into. I look at 10, I look at 15, and I look at 3, and I ask myself, what number can I create that all three of those divide into? And oftentimes what people do is they start with the largest, which is 15, and they start listing the multiples of 15 until they come up with one that all three of them divide into. So 15 is the first multiple, but 10 doesn't divide into that. The next multiple of 15 is 30, and 30 is in fact a multiple of 10 as well as a multiple of 3. So all three of these denominators divide in to 30, so the least common denominator is 30. Now notice that I did that without prime factorization. A lot of textbooks, when you start working with rational expressions, will talk about prime factorizations, which technically comes into play and is absolutely correct and useful when you have variables, but I'm going to do this without prime factorizations in this video because I think most people get a little confused by that. So then, just a quick reminder here, if you wanted to rewrite each of these with your common denominator of 30, you go back and you rewrite each one of them as equal to something over 30, and then you have to go back and figure out, well, what do I have to multiply by to turn that denominator into 30? And in this case, you'd have to multiply by 3, and so if you multiply by 3 in the top and the bottom, you get 9/30. Again, this is what you learned when you first learned about equivalent fractions. And that's the process that we're going to really apply when we start having variables. So let's look at one that has variables in it. 3 over 10x squared, 2 over 15x, and 1 over 3x to the fifth. Well, the first thing I do is I look at the coefficients, the numbers involved, and I basically treat that the same way I did in the problem above. The coefficient that's going to be involved in my LCD is going to be the number, the smallest number that all three of these divide into, and you'll notice they're the same as the numbers I had above. So my LCD is going to involve a 30. Then if I look at the variable parts, notice these all have the same base. I've got an x squared, an x, and an x to the fifth. The least common denominator has to be something that all three of those divide into evenly, which means that it has to be the one with the highest exponent. So I've got an x squared, an x to the first, and an x to the fifth, and so my LCD is going to be 30x to the fifth. Basically, this is the thing that I can build all of these up to. So now if I want to rewrite my fractions with the LCD, I do what I did up above. I start with the original, and I write it as a fraction with that new LCD. And then I ask myself, what do I have to multiply by in the top and the bottom so that the denominator becomes 30x to the fifth? Well, to turn a 10 into a 30, I need to multiply by 3, and to turn an x squared into an x to the fifth, I have to multiply by x cubed. So this is going to be 9x cubed over 30x to the fifth. The other one, 2 over 15x, if I rewrite that as something over 30x to the fifth. Let me move this equal sign over a little bit. If I look at the 15x and I want to build it up to 30x to the fifth, I have to multiply by 2x to the fourth. And since I'm putting that in the denominator, I also have to put that in the numerator. So this becomes 4x to the fourth over 30x to the fifth. And the last one, 1 over 3x to the fifth, if I want that to become 30x to the fifth, the x is already correct. I just need to put in the 10. Okay, let's try one more. Find the LCD of 5 over 3 x squared y to the fourth and 1 over 12xy to the fifth. Okay, so again, I'm going to look at the number first, the coefficient, 3 and 12. And the LCD is going to involve the smallest number that both of those divide into. So if I had a denominator of 3 and a denominator of 12, the least common denominator would involve a 12. And then if I look at the variables, one at a time, a base of x, this one has an x squared and this one has an x. And remember, I'm going to be building these denominators up to something. So I'm going to have the highest exponent, which is an x squared. And then for the y's, I've got a y to the fourth and a y to the fifth. Knowing that I'm building up to something, I've got to have a y to the fifth. So that's what my LCD is going to be. And then if I want to rewrite these with the least common denominator, I'm going to just rewrite this denominator as the LCD, and then I go back and figure out what's missing. So to turn a 3 into a 12, I need a multiplier of 4. The x squared is already there, but this is y to the fourth and that's y to the fifth, so I need a y. So I'm going to multiply the top and bottom by 4y, and then that's going to give me 20y over 12x squared y to the fifth. And for the other one, 1 over 12x y to the fifth, I'm going to rewrite that as a denominator of 12x squared y to the fifth. If I go in and I figure out what I'm missing in this case, the 12 is there. This only has an x to the first power, so I need an x to build up to x squared, and the y to the fifth is already there. So the x is the only thing missing. So this is going to be x over 12x squared y to the fifth. Now let's look at some that you're going to have to factor first. I've got 4 over x squared plus x, 3 over x squared, and 1 over x squared, 1 over x plus 1. So in order to build an LCD for something like this, you have to make sure that all of your denominators are factored. So this one is really 4 over x times x plus 1. This one is already factored. And this one, I can't factor the x plus 1. So the LCD is going to be built, there's no numeric coefficients other than 1. So the LCD is going to be built out of those variable factors. And if I look at the like bases, this one has an x to the first power and this one has an x to the second power. And this one over here doesn't really have a base of x. This x plus 1 is sort of like this factor over here. So since I need the highest exponent with like bases, I've got an x to the first and an x squared, so my LCD is going to involve an x squared. And then for these other factors, this is x plus 1 to the first and this is x plus 1 to the first. This one, the middle one, doesn't have an x plus 1. So my LCD is just going to involve an x plus 1 to the first power. So that's my common denominator. So then when I rewrite each of these with a denominator of x squared times x plus 1, go back and figure out what's missing. Well, in this first one I'm missing an x. So this will be 4x over x squared times x plus 1. If I do 3 over x squared, and I want to rewrite that as a denominator of x squared times x plus 1. The thing that's missing is the x plus 1. So this would be 3 times the quantity x plus 1. And for the last one, I have 1 over x plus 1. If I want to rewrite that with x squared times x plus 1 in the denominator, then what's missing there, let's see, x plus 1, I want an x squared, so I need to put in a multiplier of x squared here. Okay, one more with variables and then we'll be done. Okay, again, if you've got terms in your denominator, then you need to factor them. So this first one, m squared minus 9, that's a difference of two squares, so that's m plus 3 times m minus 3. And this second one, let's see, I think that's going to be an m minus 3 times m minus 2. So there's really only one factor that's in common in them. This has an m minus 3 to the first power, and this has an m minus 3 to the first power. And the other factors aren't in common. But remember, my least common denominator is the product of all of my factors that I can build everything up to. So it has to include everything that shows up. So there's an m plus 3 here. It's not in the other one, but that means I need to include it in my least common denominator. There's an m minus 3 to the first power here and an m minus 3 to the first power here, so that's all I need since the first power is the highest exponent. And then this one over here has an m minus 2, and even though it's not in the other one, I still need it because I need my LCD to be something that all of these original denominators divide into evenly. So my least common denominator is kind of messy in that it involves three factors, but it is what it is. So then if I go back and I rewrite this, and I want it to have the common denominator, it's pretty easy to see what's missing in this particular case. What's missing is the m minus 2 in this first one. So you're just going to have m times m minus 2. In the numerator, sometimes people will distribute and multiply things out. In the denominator, you pretty much never want to. So the second one, 5 over m minus 3 times m minus 2, if I want that to have the denominator of m plus 3, m minus 3, m minus 2, the piece that's missing is the m plus 2. Excuse me, the m plus 3. So this will become 5 times m plus 3. So that's a quick review of how to find least common denominators or build them, and then how to convert your fractions to have that common denominator.